When a machine breaks on the floor or a batch fails inspection, the natural human instinct is to apply a quick Band-Aid and get production moving again. But focusing on the surface often leaves the underlying mechanism untouched, allowing the same issue to cycle back into production while draining time and resources. To cut through those superficial symptoms, quality teams rely on a structured questioning methodology known as the 5 whys. Shifting focus from visible symptoms to investigating the source is the baseline for a quality control system that prevents problem recurrence. Sakichi Toyota developed this technique as a core component of the Toyota production system. It was designed to trace assembly line defects to their origins. Today, the tool is used to simplify complex manufacturing failures into clear, logical cause and effect relationships. In modern pharmaceutical production, uncovering these underlying reasons is a requirement for corrective and preventative actions, ensuring strict GMP compliance. Take a common scenario from the production floor. A pharmaceutical batch has failed its dissolution test. We ask why the batch failed. The answer: the tablets didn't dissolve. Why? Because the granules were formulated too hard. So why were they too hard? The investigation shows excessive drying time. Why? Because the operator followed an outdated standard operating procedure. This leads to the final question: why was an outdated SOP on the floor? The team discovers the facility's document revision control was not effectively implemented. 5 targeted questions turned a physical product failure into a systemic fix that addresses the root of the issue. For the process to work, every answer in the chain must be backed by verifiable facts and data, not assumptions. This aligns with WHO. Edwards Deming's philosophy that bad processes, not bad people, cause failures. In this framework, human error is never the stopping point for a root cause. Investigators stop asking why only when the cause becomes systemic or leaves their sphere of control. The 5 whys is an instrument for process investigation, not a means of personal accusation. Consider another example in the lab. A technician receives an out-of-specification, or OOS, result for a standard assay. The assay was OOS because of an incorrect sample dilution, which happened because the analyst used the wrong pipette. Why was the wrong pipette used? Its labeling was unclear, having faded after contact with a harsh cleaning solvent. The final why reveals that the labels were never replaced because the lab lacked a preventative maintenance schedule for equipment labeling. Implementing that missing schedule ensures this specific chain of errors is broken at the source. The 5 whys is effective because it is simple. It requires no statistical software and relies entirely on logical teamwork between departments. A common mistake is stopping the process early, before a true systemic failure is identified. Teams must avoid using the process to justify preconceived solutions, instead of following the evidence. Success depends on documenting the reasoning chain clearly and avoiding assumptions at every step. Remember, broken processes are the source of most failures. Consistently following the evidence downward uses daily manufacturing problems as a roadmap for making structural improvements to the facility. Apply these principles to investigations to achieve strong GMP compliance, and subscribe for more pharma training.